This is the second part of this Python session, and this is about this essential Python for data science. And in this particular session, I would like to talk about a few more important and essential modules of Python, which will help you to get started quickly, and you can progress pretty fast on many data sets. So let us look at this, and the second module I would like to cover is Pandas. Pandas is a Python package for handling large data sets. It is essentially extremely useful excuse me, when you're trying to manipulate data frames. Data frames, you can visualize it as a large table. Let's think we are trying to read an Excel spreadsheet, either as a CSV or a XLSX, etc., into Python. And the way we would do that is to use the Pandas module. So you can just import the entire CSV or Excel sheet into a Pandas data frame, and then you can manipulate as appropriate. So let us get started. So excuse me, Pandas, to get started, you will have to call import Pandas as PD, and you import this model Pandas as PD. So Pandas has two main types of that it manipulates with. One is the series. So Pandas series is similar to what we saw as in a NumPy array. Is basically you pass a list into this call pd.series, and it'll create a Pandas series for you. So let us create this, and let us display this Pandas series. So it has index 0, 1, 2 and 3. So now you may think it's just basically like a NumPy array, but the difference is that this series, you can actually specify the index. Instead of it being 0, 1, 2, you can specify any specific index. So we pass a list for the values, and we also pass a list for the indices. Now if I display this new series object2, I will find that it is going to have this new indices D, B, A and C. Now I can check the indices of object2, which is object2.index, or I can check the values of this, which is object2.values. I can also obtain the value from a specific index. So for example, if I wanted to check the value at index B, I can just do object and within single quotes I can give the index B, and it will pick this the value that is corresponding to this particular index B, which is 7. Okay, now that is basically a series. The other important type in Pandas is the data frame, which is the most commonly used. So example, when you're trying to do any data analysis of any data set, which typically will be as a CSV or a tab separated data, or it could be as an Excel worksheet, you typically would be using this Pandas data frames. So here first let us create some simple data frames. So this data frame, I start with the data, which is essentially I create a dictionary. And so a dictionary, you start with curly braces and end with curly braces, and within the dictionary I have three elements. One is the state, and the state value is actually a list. Then a year is again, colon is again a list, and a population is again a list. So now let's look at this dictionary, and so I look at this contents of this dictionary. Hold on, what happened? Excuse me. So this is the contents of the dictionary. Now I cast this dictionary into a data frame. So the way you do it is called pd.data frame. Notice that you have a capital F, and you create this data frame. So it creates a data frame. You see it has three columns: population, state, and year, and it has 5 rows. Okay, so basically from this dictionary, with you had 5 length of the list was 5. So you have 5 rows and 3 columns. Okay, you can also create a data frame from an array. So basically, if I create an array of range 20 and reshaped as 4, 5, I can pass this array into this pd.data frame, and I will get a data frame. But you would not typically tend to use this, but if the thing occurs, you can still use it. And you can get the shape of the data frame, which will give the number of rows and columns the same way as you got with arrays. So you just say df.shape, it says 4 rows and 5 columns. Now let us look at this new data frame. Again, I'm creating a data frame, and data frame you can actually create data, and then which you created here, and then you can specify the names of the columns. Okay, so let us say I create instead of the normal 0, 1, 2, I create index 1, 2, 3, 4, and 5. So that will the same data frame, but I have the indices 1, 2, 3, 4, and 5. Okay, and I also have a new column called det here, which was not there initially. So since it is not there initially, it is filled with NaN or not available values. Okay, again I can check the shape of this data frame, which is 5, 3. I can check what are the more information of the data frame. I use frame 2.info, and I can check the names of the data frame, which is with frame 2.columns. So what are the columns in the data frame? Okay, how do you subset data frames? This is very similar to the way we subsetted NumPy arrays. So no, there are 2 ways to subset data frames. The first is you want to use indices, that is, you want to use row index and column index, and this particular method is using the iloc call, and the format is essentially the same. That is, you have the start row, end row, and colon, and start column, colon, end column. So you say let's first print this frame, which is this data frame. Okay, and then I subset this data frame. That is, I take iloc, which is I basically index by numerically. So basically I index starting from the first row and up to the third column. So I index from the first row up to the third column. So 201 to 201. Index from the first row up to the first up to the third row, and first column up to the third column, which will give me these 2 values. Oh, higher 201, higher 202. Okay. If only want to display, alternatively I could also do frame iloc 1 to 4, from the second to the fourth rows, frame 1 to 4 up to 2 to 3. Or I could also display, if I wanted to just display the row with index equal to 1, I just say I use the log call. Okay, so here I will only display the all the rows with index 1 up till 4, 0, 1, 2, 3, and 4. Okay, so basically what I need to understand is there are slightly different ways to subset data frames. The first is using the iloc, and in iloc you will be using numerical indices, and this is very similar to the way we subsetted arrays. You have a start row, colon, end row, start row, start column, colon, end column, and remember the row and column start with the index 0. So, and the start row to end row, the end row is basically up to the end row, not that exact row. So up to the end row, and the start column, colon, end column. And when you use this frame.log, basically it will pick the row with that specific index. Okay, so for example, if I had just gave frame.log let us say 2, then it will pick just the row with that particular index. Hold on. So it is just pick this particular one, which is 3.6, this row index thing, and it will display it here, Ohio 202. Okay, so that is that. Now let us quickly. Okay, now let's see how we can import Excel files or CSV files into Pandas. Okay, so now what you need to do is to set the directory to the directory where you have downloaded the Python notebook. Actually, GitHub will also have two other files along with that. So if you look at the GitHub repository where you download the Python notebook, it will also have two other files which I would also which were downloaded along with the Python notebook. One is the gas card or XLS. The second one is Tendulkar.csv. So what you need to do is you need to go change to the directory where you have downloaded the zip file. In my case, it is c/, essentially essential Python for data science, master essential Python for data science. And then once I have set this directory, I then call pd.readcsv Tendulkar.csv, and then you give this encoding type for the CSV file, and it will read the CSV file. Now let us do this. So I'm just importing the CSV file into a Pandas data frame. So you see that it displays the top 5 rows of this particular data frame or the CSV file. So this has these columns, runs, minutes, balls, face, 4, 6s, etc. And there's also, you can also import Excel files, Excel, XLS and XLSX formatted files. So here I'm trying to see what pd.read_excel does. So you can actually give the Excel file name, and you can also specify sheets. If you had multiple sheets in the Excel file, you can specify the sheet name also. Here I have okay, so it's very convenient and very useful. So I'm going to import this Excel file gas_car.xls, and I'm going to read the sheet name car.data. Okay, so if I read it, I see that it has these it just shows the top 5 rows. And what I just wanted to point out was that Pandas is great when you're trying to read CSV files, XLS files, and Excel files. You can in fact have multiple sheets. You can read multiple sheets. You can write out to Excel files. You can write out to multiple sheets in Excel files, and there are many things you can do with Pandas. Now that you've seen how to read in Excel files and CSV files, etc., I want to touch upon some of the functions which you use very commonly in Pandas, and I suggest that you try to get familiar with them as quickly as possible, because this is what you would be using whenever, however large your data frame is. So the first is, you after having read your CSV or Excel file into a particular data frame, then you call dataframe.head to see the top 5 rows of this data frame. Hold on, it's not showing up. It's because okay, the top 5 rows, you do Tendulkar.held. If you want to see the bottom 5 rows, you do the data frame dot tail. To see the shape, that is number of rows and columns, you do data frame dot shape. To see just the column names, you can type data frame dot columns. So you have number, runs, minutes, balls, face, etc. This is another very useful command. Tendulkar that is data frame dot info will give you the type for each of these columns. So it says there is a serial number which is of type integer, and then you have all these are basically string objects, runs, minutes. Even though runs should have been a numeric, it is in this particular case, after having read it, it's written as a string. Okay, now if I wanted to change the names of the columns to something more appropriate, then I would probably I just have write Tendulkar.columns, and then I give a list of the column names which I'm interested in. And if I now look at it, then I will find that it has this specific name which I assigned to it. Okay, let us say NUM in this case, for example. Okay, so then if I type Tendulkar.head, it will have number here. Okay. Now a very important thing that you would often be doing with data sets is that data sets typically you get will be unclear. That is, you will have a lot of blanks, you will have some extra characters in the data frame, and you'll have a lot of unwanted stuff which you would want to remove. So you would first have to clean the data frame before you actually do any manipulation. You try to find any insights, you apply any analytics, or you want to do any machine learning. You first have to clean the data frame. So I just show some basic cleaning techniques. So in this data frame, you see there is something called DNB for the runs, which is basically did not bat. And there's also, if you go below, you'll have something called TDNB. So I'm going to be removing these particular rows, and the way to do that is I'm going to create a logical vector. Okay, I'm going to take Tendulkar. I'm going to select all rows which are not which do not have the DNB and which have a regular number, and I'm going to assign it to a variable A. Okay, and since I'm making a logical comparison, this A will actually be a logical vector of trues and falses. The rows which are false is where it's DNB, and the rows which is true is where you have a regular number. Now I subset this, I remove all the rows which have this DNB by subsetting this Tendulkar data frame by using this logical vector. So this logical vector is A. I just subset this data frame with this particular logical vector, logical list, and I get this. I remove the rows which have Tendulkar, that is, it has DNB in the runs column. So it has. So if you looked at it before, let us go through this again. If I had read this originally, okay, I read Tendulkar, and now if I let us say before I do any of this, if I looked at the Tendulkar.shape, it has 347 rows. Then I assign a logical vector A by getting all rows which do not have DNB, and I subset this data frame, and I now check the size of this data frame. If you look at it, it now only has 330 rows, so it has removed all rows which had this DNB. Next, I create another logical vector B, logical list, where I remove all rows which have this TDNB, and I then subset this data frame with this logical list. And if I check this new data frame, the size of it is 329. So one row had TDNB, and then I remove a column of the runs in the. There is also a star, a hyphen character. So I remove that from the runs. And then I also remove the star character from this. And now if I check the shape of this data frame, it is 328 rows. Okay, so now we have seen how to remove rows which have some specific characters. Now let us, as I said, we had a way of subsetting data frames by using the ilock and the lock. The other more prevalent way is to select specific columns by just giving the column names. And the way to do that is you provide a list of the column names, and within square brackets you provide the list. So that's why you have these two square brackets. So here I select the runs, balls faced, and ground. So if I first, let us look at the Tendulkar data frame. I will first look at the Tendulkar data frame by choosing the head command. Okay, so I'm going to just choose runs, balls faced, and the ground. Okay, so I'm just going to choose these three columns. So, and I'm going to create a new data frame called df1, and if I look at this, the head of this column, the new data frame, it just has these three columns. That's one way of subsetting data frames. The other one is if I want to filter out rows where the ground is Karachi. So here what I do is I select the column ground and I check if it is equal to Karachi, and assign it to a logical vector A, and then I subset this Tendulkar data frame with this logical vector or list. I keep using the term vector because that's what you use in R, but here it is a list. Okay, so I create a logical list and then I create a thing, so it picks up all the rows which where Tendulkar has played in Karachi. Okay, now I could have done this both these three operations in a single row, in a single step. So I just subset, find all rows where it is Karachi, and then I subset it instead of first assigning to a logical list and then subsetting it. I do this whole thing in a single line. So again, it is the same thing. Okay, now the next thing I want to show is, let us say I want to find out all rows where Tendulkar has scored more than 50 runs. Now this will give me an error because we saw before that when I saw info that all the rows were of type object, they were not numeric. Okay, so that is why this is giving an error, and typically just for people who are starting new on Python, it gives a big dump. Okay, this will give a huge stack dump, and don't get too worried about it. Just note, you see where it is giving this error. So this particular line where I'm trying to check the greater than sign, it's giving an error. Then if you go down, it says greater than sign not supported between instances of string and int. So that really happened because this runs column was of type string and it was not integer. Okay, so we can check the type of this particular runs column. I just check, pick the first element, that is Tendulkar.runs column, pick the first element, and if I check the type of this, it says it's a string. Okay, so that's why it was giving this error. So what I need to do is I will need to convert the runs column into numeric. So a very useful function in Pandas is the PD to numeric. So it will convert this column to numeric. So I'm going to convert both the runs and the balls faced to numeric. Okay, so the way to do is PD dot to numeric, and then I pass the column Tendulkar runs and I assign it back to the same column Tendulkar runs, and similarly I do the same thing for balls faced. Okay, now let me do this same thing. I converted numeric. Now let us say I want to I select all rows where Tendulkar has scored more than 50 runs. So here I pick the column Tendulkar runs and check for greater than 50, and then I subset that from the data frame. Okay, so I check that. So here it has dumped this, display the top 5 rows, and if you see the runs, it is all greater than 50. Okay, another thing you would do with data sets, whatever be the data set, is you'll have to deal with dates. So to make Pandas understand the date format, and your date format could be anything. It could be a month, day and year, or it could be day, month, year, or it could be year, month, day. You have multiple formats, right? So you probably want to convert, Pandas wants to convert to a common format it can understand, and the way to do it is you pass the column name which is of type date, and you pass pd.toDateTime, and you assign it back to the same start date. So Pandas now has a common way to understand. So for example, what Tendulkar.startDate, if you see the format here, it is of this format, and now if I convert it to this pd.toDateTime, okay, sorry, okay, and now let us look at the same Tendulkar.startDate. it would have been converted into an internal uh, sorry, internal pandas format. Okay, so that's how it is internally converted. Now once I've converted internal pandas format, I can now do operations like, get me all rows, all the games where the start date is greater than 2005, January 2005. So I check, first assign it to a logical vector, then I subset it. This I can do it in a single line here, and I check the first 5 rows of this new data frame. It is all, you look at the date, it is all above greater than 2005. And we saw iloc where you could subset it using indices. So I can use iloc from row index 1 to row index 4, or from column index 2 to column index 6. So that is one way of doing it. Or I could use the loc. So this is another way of subsetting data frames, besides actually using some criteria to filter rows, or some criteria or to select the column by column names. You can use the iloc or loc. Okay. So you can also drop common if you have NAs in your column, you could drop it using drop NA. Okay, so this is another way to do it, and you can check the shape. After dropping it, it will give you the shape. So that is another way. Now let us look at some interesting operations which you would do on data frames. Typically, one is just you want to get the mean of some particular column. You can just select the column and then call the mean function. So its average was 48.50 runs. Or you could select the columns runs, balls faced and ground for the data frame, group by ground, and get the mean. Okay, for each of those grounds that you played. Okay, so and you can also what you do is, and you assign it to data frame A, and then you sort the values by runs, and then you display this data frame. So let us see what it does. So you have grouped the games by his ground, and you pick the mean of his runs and balls faced. So he has Multani has scored 194 runs and faced 348 balls, and so similarly it does that. It is also sorted it in descending order, and I have done this in thing. So I could have, instead of writing this as 3 separate statements in Python, you can write it as a single statement, and this is how it works. So basically here I select these 3 columns, I group it by ground, I then get the mean of the runs and balls faced by each ground, and then I sort on the runs in a descending order. Okay, so that is what that means. Okay, the other if you want to do, you can also group by opposition, find the mean and sort it in descending order. Let us see what you get with this. So against Bangladesh, he has an average of 91 runs. Against Zimbabwe, 65 runs. West Indies, 50 runs, and so on. So this is a very easy way of doing it with pandas. Okay, what else you can add? So yeah, so you can also compute not just the mean. You can compute the mean, sum, and count. Okay, you can group again by ground, and you can do an aggregate function and just do sum, mean, and count. So it will display all of this in one shot. Let us display what it found. So you see, for each of this, it got the sum, mean, and count. So in Adelaide, he has played 10 matches. His average was 32 runs, and this was the total number of runs he scored in Adelaide. So you can do all of this in one shot in pandas. Okay. Then another useful command in Python is lambda and map operations. Let us assume we have 2 lists, A and B. Okay, so and then we want to do an element wise addition of these 2 lists. So we create a lambda function. Lambda function is like an anonymous function. So basically you don't give any function names, lambda xy parameters, and you say what you want to do, x plus y. So what I do is I call the list function, because since both are list, and then I call a map, and then I do an add. So basically for each corresponding element of each list, it's going to apply this add function, okay, for these two lists A and B. So if I do this, it's going to give me 5 plus 1 6, 2 plus 5 7 is going to do that. Or I could do an element wise multiplication if I wanted, element addition, or an element wise multiplication, element wise subtraction, or element wise multiplication here. Yeah, okay, so that's what it is. You can also do this also on a data frame. So for example, we had let's say we have this force column in Tendulkar, and I wanted to multiply or do some operation on all the elements of this particular column. This column is each column is a series, okay. So I just to apply something common function, I just call apply lambda function. So I take each element of this particular column, so each row of this particular column, and then I multiply it by 4. So just basically, let's assume we want to compute the runs for each number of 4. So here it's going to multiply each of those particular 4s with 4 runs, okay. So that is what that is. So here I could, for example, if I had a list 1 2 3 4 5 and I wanted to do a square of each element, I can just do a list, a map lambda, and I take the square, and here's a simple function for converting Celsius to Fahrenheit. Okay, you just apply this function, which is float 9 by 5 plus 32, which is your way to convert, okay. And how do you create Python functions? You just do def function name, the parameters, and colon. Remember, Python does not have curly braces. The way instead of braces you use an indentation, and indentations have to be exact. So the start of your curly braces is implied by this colon sign, and then every line which is indented means it's all the block within that function, and then you just call product, the function name, and you pass in the parameters, so it'll compute the function. So this is a very important thing you need in Python, how to create functions. And something that we use very common is Matplotlib, which is used for creating plots in Python. So here I'm going to the way you do this, you import Matplotlib pyplot as plt, and then you do if you want to do a scatter plot, I would just do the x scatter plot, the x variable and the y variable. Then I can give the title, the x label, the y label, and you also always have to end it with the plot show to actually display the plot. So here I'm displaying it, so it'll display this particular plot. So see, if you see, it has actually displayed the plot here. Scatter plot, ball space, runs and Tendulkar runs was also with the title. So here I'm actually creating a histogram of the runs that he scored. You see, we have to use the plot show to actually display the plot. So it displays this histogram, okay. Now that is all I had for this session, and let us quickly. So now quickly recapitulating on the things covered in this session. I mean, Pandas is a very important Python package, and it essentially helps you to manage series data and data frames. And you need to import the Pandas module as PD. And here we saw how to create a Pandas data frame from a dictionary. You just create a dictionary and then call the pd.data frame and the dictionary name. You can also create it from an array, and again call pd.data frame an array, and some important frame commands are frame.shape, which will give you the shape, frame.info, which will give you details about each of the columns and what type they are, and the column names. There are several different ways to subset data frames. One is to use the ilock and the lock. With the ilock, you can use the row indices and column indices, start row colon end row, start column index colon end column index, very similar to the way you index arrays. Or you can use the lock, where you index by row index. And here we saw how we can use Pandas data frame to read CSV files. We can read Excel sheets, and you can in fact read sheet names from individual sheets from the Excel file, or you can also write to Excel with sheet names. The most important data frame operations are head, which will display the top 5 rows, tail, data frame.tail will display the bottom 5 rows, shape, which will give you the number of rows and columns. The columns will display the column names, and info, which will give details about the type of each column. And you can rename the columns by typing dataframe.columns and giving a list of the column names. And then we saw how to clean data frames. So for example, if you had to remove certain characters, you can create a logical vector by comparing it to that particular string, and then you can subset based on the logical vector. So we have seen that, and then you can replace any specific character by doing .str.replace, and you can also subset based on other criteria. So for example, you can subset rows by filtering a particular column with the row with a particular row name. So here we have filtered the ground with Karachi, so you get all the games where he played in Karachi. And you can select columns by providing within square brackets a list of column names. So this is how you subset columns. And you can convert to numeric using pd.toNumeric, and you can then use a comparison operator. And again, subset runs greater than 50. You can, if you want to manipulate on dates, you need to use pd.toDateTime, and then you can just say greater than some date or less than some date or between two dates. You can select specific rows. You can also do drop any to drop rows which have null drop a names. Very useful command. And then we saw how to group by a certain criteria. We group by ground and compute the mean, and then also sort the values in descending order of runs. You can do it in a single line. Just select the columns you're interested in, group by ground, get the mean, and then sort it in descending order. Okay, so that is one. You can also do multiple aggregation, like for example, you can compute the sum, the mean, and the count of a specific columns after grouping them by some criteria. And then you saw how to do the lambda operations. You can take you can create a lambda with like an anonymous function, and then call list and map, and then apply the lambda function on list of elements. You can also use lambda on a column. So an entire column, you want to apply the same operation, you can use the apply and then call a lambda function on the entire column. You can convert a Celsius to Fahrenheit by calling a list map lambda, and you define a function by using the def function. Def function name, and then the parameters are colon. There's no braces. Instead of the braces you have the colon, and then you use the indentation to identify the block, and then you call the function with the function name. And then for plotting you use Matplotlib. There are other plotting modules available in Python, but here we're talking about Matplotlib. So here I've given plot a scatter plot. I give x and y variable, then I use the title, x label and y label, and you have to use the plot brochure to display it, and then you get the histogram. So that concludes this Python session. So these are the most important commands that you would need, you would be using in Python, and it will help you to get started off in Python. And as you become more proficient, you can probably pick up some of the more interesting aspects, like for example inner joins, outer joins, multi-indexing, and things like that. So you can look that up in Google, or you can probably look up at Stack Overflow. So hope you have a good journey in Python. Thanks for listening.